Hey guys, this week's lesson is going to be all about heat and temperature. And what you should do is print this out or download it and have it open while you watch the video that I made. As you watch the video that I made, this one, you're going to fill this out, okay? It'll just help explain it a little bit better. All right, so we're talking about heat and temperature. Temperature is a measure of heat. There's really no such thing as cold. Cold is just a lack of heat or a little bit of heat. When you don't have any heat, that's what absolute zero is, okay? So temperature is a measure of heat. Heat is the measure of the average kinetic energy of the particles in an object. Kinetic energy means energy in motion. Okay, when molecules are moving, they're hitting each other and causing a little bit of friction. So kinetic energy describes particles in motion. The faster the particles move, the more heat. The slower the particles move, the less heat. Okay, so if particles stop moving, this is called absolute zero, which means the absence of all heat, no heat. So think of kinetic energy as friction. If I were to take an eraser from a pencil, and I rub it on my skin, and I keep rubbing it in the same place, it starts to get hot, and eventually I'm going to get a burn, so don't try this at home. But that's kinetic energy, all right, the friction. I'm rubbing particles together, and the more I rub them together, the hotter it gets. The faster I rub it, the hotter it gets. Okay, so temperature is a measure of how much particles are moving. And the more they're moving, the hotter it is, the more heat. And the slower they're moving, the less heat. Absolute zero is 0 Kelvin. Kelvin is the standard unit of measurement for temperature. And Kelvin does not have any negative numbers because you can't go any lower than no heat. All right, so if I'm measuring heat and I'm measuring these particles moving, slower, 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 stop. You can't go slower than being stopped, okay? So absolute zero, the Kelvin scale, that's how it's measured. Let's look at those scales now. There are 3 different temperature scales that we use in modern times. Fahrenheit is what we use here in the United States and some other English-speaking countries, but not very many. Most of the world uses Celsius, so you guys might be more familiar with Celsius than I am. But the scientific community uses Kelvin. And Kelvin, again, is the standard. Okay? So freezing in Celsius is 0 degrees. In Fahrenheit, freezing is 32 degrees Fahrenheit. And in Kelvin, freezing is 273 degrees Kelvin. So if you look at the boiling point of water, Celsius, the freezing point is 0, and the boiling point is 100 degrees Celsius. In Fahrenheit, the freezing point is 32, and the boiling point is 212. And in Kelvin, the freezing point is 273, and the boiling point is 373. So you'll notice all 3 of these scales are just adding 100 degrees between freezing and boiling. So that's where they're the same. Where they're different is where the starting point is. At this point, you guys are going to have to be able to convert between these things. I've included all the formulas for you to use as you go through the next page of this worksheet. Okay, I'm going to show you how to do it so you know what you're doing for the rest of this paper. You're going to be filling in the chart, converting everything from Celsius to Fahrenheit to Kelvin. So the first thing to realize is I have 21 degrees Celsius. That's room temperature. I want to know what that is in degrees Fahrenheit, and I also want to know what that is in degrees Kelvin. So I'm going to use the equation. I know that degrees Kelvin is equal to degrees Celsius plus 273 degrees. I know that from the formulas. So I'm really just going to plug that in. This one is simple to me. I know my Celsius. I just have to add 273, and then I'll know Kelvin. 273 plus 21 is 294 degrees Kelvin. Now, in order to go from Celsius to Fahrenheit, I have to know that the equation, when I'm looking for degrees Fahrenheit, is equal to 1.8 times my degrees Celsius, so that's 21 degrees Celsius. Once I multiply that, then I add the entire thing to 32. 1.8 times 21 equals 37.8 plus 32. 2 equals 69.8 degrees Fahrenheit. Okay, so 21 degrees Celsius is 69.8 degrees Fahrenheit and 294 degrees Kelvin. If you have Celsius, you can find Fahrenheit. If you have Fahrenheit, you can find Celsius. If you have Celsius, you can also find Kelvin. But what if I ask you to find Kelvin and I've given you Fahrenheit? Let's say it's 80 degrees Fahrenheit in this classroom. What does that equal in degrees Kelvin? Well, I don't have a direct formula to give you that information. So the first thing I have to do is find Celsius. This way, I can plug my Celsius number in and then find my Kelvin. So step 1, find Celsius. So let's do that, okay? I'm going to plug it into this equation because I'm looking for Celsius. So 80 degrees Fahrenheit minus 32 equals 48. And then I take 48 divided by 1.8. Okay, so now I know Fahrenheit minus 32 is 48. And then divide that whole thing by 1.8. So 48 divided by 1.8 equals 26.66666, so I'll just say 67 degrees Celsius. Since I have this number now, I can easily find my Kelvin. So 26.67 plus 273 equals 299.67 degrees Kelvin. So that's really going to be the only one that would be tricky. Everything else is self-explanatory. If you have it, plug it in. If you have it, plug it in. Okay? But if there is no direct link between, say, Fahrenheit and Kelvin, it's a two-stepper. You know you can find Kelvin if you have Celsius. So first find Celsius, then you can find your Kelvin. All right, I hope that helps. Good luck with the chart that you need to fill in. Stay tuned, and I'll show you part 2 of this week's assignment.